Okay. Here we go.
I get it. I got it.
All you guys can yawn at each other and tease them at the test grades. Let me get them all graded first, okay? Then you can draw them up. Right now, we're focused. How many ways can you arrange 5 books on a shelf? Does anybody have any idea? I heard 5. Do I hear any of? I hear 25. These are reasonable guesses, both incorrect. Can you think of another idea?
It's
500.
It's 125.
125. Well, we're getting closer. All right, here's what I want you to think about. I want you to think about what this, here's my bookshelf. And I have room for 5 books on my bookshelf. So here are the 5 books. All right, so I'm going to reach down and grab one and put it in the first slot. How many choices of books do I have? I'm only going to pick one, but how many choices do I have? 5. So there are 5 possibilities for that first slot. Then I'm going to reach down. So I pick one, put it there. Okay. Now I have to pick another one. How many possibilities for the second slot? 4. Because one book has already been put in place. So now there are 4 possibilities for this. How many possibilities for this?
3.
3, and then 2, and then at the end there's only 1 book left to put in that spot. These possibilities or options get multiplied.
20, 60,
So
120.
the answer is all of these times each other, which is 120. Now, that was not bad at all. What if there had been, what is the next problem? 9. Okay, now we have 9 people in a line. 9 people in a line is exactly the same idea. Do you see that? I'm going to pick a guy to stand right here. I have 9 choices. And then I have 8 and 7 and 6. So for question 2, it would look like this.
362,880.
Now, that, you'll have a calculator in this whole thing. So having a calculator, that's great. Here's multiply all this together. But that is quite tedious. Your calculator will do this for you. The idea that we have here, when we do 9, 8, 7, 6, that is called 9 factorial. And the symbol for the factorial button is an exclamation point. This one would have been 5 factorial. So to get the factorial, press 9, we'll do this one, press 9 on your calculator, then go to your math menu, your math, click across to the prob menu, and you see the exclamation point in there? So you go down there and click enter, and it should be the same number Dana gave us, 362,880, is that what you said?
Yeah, I did it in my head though.
So that is the way that if you are arranging things in a line, so if I were going to arrange 10 dogs in a row, it would be 10 factorial. If I were going to arrange, 16 plates in a row, it would be 16 factorial. Okay, does that make sense to you? That's kind of your first rule. N things in a row is n factorial. Okay, Joe? N things in a row is n factorial. All right? Okay. All right, let's move on to the next question.
Wait, how did she get that?
How many ways can prizes be awarded for first, second, and third place in a race with 10 contestants? Now, please do not say 10 factorial, because I'm not arranging all 10. They're not all 10 going to get a prize, right?
First, second,
only first, second, and third. So what would that look like?
Factorial.
10 times 9 times 8.
Oh.
How many people could win
720.
first prize? How many choices
3.
for first prize?
720.
No, there's 10 people in the race. How many options do I have to win? 10. So you won, all right? How many options do I have for second place? 9. You won. How many options do I have left for third place? 8. And then I stop because I'm only doing 3 places,
720.
right? So the answer would be 720. Now, that's an easy one, that's not much to multiply, but your calculator will do this for you also. If you have 10 things, in this case they were people, but 10 things, and you are choosing just 3 of them, and the order you choose them matters, okay? Now think about this for a second. If I am choosing first, second, and third place, doesn't it matter what order I pick you in? Okay, so if you're picking 3 people or 3 things in order out of 10, that is called a permutation. Our notation would be 10p, that's for permutation. 10p3, 10 to choose from, and 3 to choose. If you go back, well, first of all, press 10, gotta start with 10. Then go to your math menu, over to prob. Do you see an NPR option? That's the one you want. Then type 3, and it says exactly what you calculated, 720. Okay? All right, so keep that in mind. All right, number 4. This sport has 8 jumpers and 10 shirts. How many different outfits are possible? All right, I'll just hold up a minute. Every day, I go to my closet, I got some jumpers, I got some shirts. You know, I'll wear anything with anything, we don't worry about matching. I have to pick a jumper, I have to pick a shirt. All right, so I am making 2 choices. How many options do I have when I go to pick a jumper?
18.
How many options do I have when I pick a shirt?
So 8.
10. The answer is 80. 80. Every jumper can be paired with every shirt. So 80.
No, could you put say a permutation?
No. Only, permutation is only when you have a group and you're picking from that one group. I have 2 groups here, and no, so no. Mr. Ford has 5 sport coats, 12 shirts, and 10 pairs of pants. Assuming that everything matches, how many outfits does he have?
600.
5 times 12 times 10. I am multiplying my options, just like I did in the book problem. I'm multiplying my options. I had 5 options for the first slot. Well, for him, he has 5 options for a full coat. And then 12, and then 10. So what is that, 600?
Yeah.
Okay. How many ways can the home row of the keyboard, so that's the letters A, S, D, F, G, H, J, K, L, be arranged? 9 factorial. How many letters are there in that list? 9. How many ways can we arrange 9 things in a row? 9 factorial. So that number that you said, this number right here.
90.
How many ways can you answer 10 true-false questions?
90.
Okay, now let's just stop for a minute. There's 10 questions. And I heard somebody say, there's 2 options for question 1. There are 2 options for question 2. And so on and so on and so on. what do I do with all my options? I always multiply them.
2 to the 10.
So 2 to the 10th,
1,024.
1,024. How many ways can 4 different prizes be given out if there are 10 people in the contest?
40, 10 times 5 times 8 times.
10 factorial.
No.
Not 10 factorial because you're
Oh,
not
yeah, yeah,
giving
yeah.
out.
10 times 8 times 10.
So you could either do it, 10, 9, 8, 7, you could do it that way, or you could do 10p4. Because there are 10 kids and you are choosing 4 of them in order because they're getting different prizes. So I don't know what that is, help me out. What? 5,040? That number right there is 5,040?
Yeah.
90 times 8.
So 20.
Interesting.
Would you give less?
No, because 7 factorial is 5,040, so it's interesting that that equals 7 factorial. It's interesting to me. All right, how many license plates are possible if they must consist of 2 letters followed by 3 non-zero digits?
There's 26
Okay.
letters.
Yeah, so just a minute, let me get a picture of my license plate. Because my license plate has to have 2 letters and then 3 digits, so numbers, 3 numbers. And the numbers can't be zeros, so any numbers but zeros. Okay? Now, there are no restrictions on this. This is what I want. I want a letter. How many choices, options do I have? 26. Now I need a letter. How many options do I have? Actually, 26. Because can I have a license plate with 2 letters the same?
Yeah.
Yes. Okay, so 26, 26. Okay, now I need a number.
10.
Or 9.
Can't be 0. Can't be 0 according to the problem. So it's 9 and 9 and 9. Because again, your license plate can have 2 3s or something, right, in it?
Yeah.
And then what do I do with all these numbers? Multiply them. So the answer is, someone tell me.
492,804. Yeah, got
Say
that too.
again.
I got that. 492,804. Yeah.
804?
Yeah.
All right, so there we go. That's the answer to the question. Now, number 10 says, we're doing the same license plates, only this time, no repeats.
So 26, 25.
So 26, 25,
987.
987, perfect. Multiply it all together,
327,600.
820, no,
300.
300.
Yeah.
27, 600. So does everyone see the difference between problem 9 and 10?
Yeah.
Okay. Number 1, how many 4-letter call signs are possible if every letter is allowed? Now, a call sign is, like every morning, I'm watching WTHR. Their news starts at 4 a.m., so I always have that on. WTHR, that's a call sign, channel 13. So, WTHR, 4 letters. So how many 4-letter call signs are possible? 26, 26. Everything's possible. It says every letter is allowed, no restrictions, that's it. So what do you say, Joe?
456,976.
All right, there we go. Now, look at question 12. No letter can repeat. So 26, 27, 25, 24, and 23?
358,800.
You say 300?
358,000.
Yeah, that's great.
Can you do the NPR for this problem?
This one, you can't do it for this one.
Yeah, yeah.
This one you can, this one
Is
is
Y a vowel?
26,
Sometimes it
54.
is. Is Y technically called a vowel in this instance? Because sometimes it is, sometimes.
All right, number 13.
Now you're
How
good.
many call signs are possible if no vowels are allowed?
Grow in the back.
There are 5 vowels, so this is it, right here.
194,481.
And then, no vowels, no repeats.
21, 20, 19. Your handwriting.
142,640.
Someone double check that, please.
Yeah, somebody's gonna double check.
Doesn't sound right.
Now, I want you to notice
You timed that
something,
by-
and this should make perfectly good sense to you. These 4 problems that all involve the call signs, when we had no restrictions at all, this is what we ended up with. As we increased our restrictions, you see what happened to our total? They went down, and that's gonna happen every time. The more constraints you put in place.
Oh,
Number 13.
wait.
If a baseball team has 9 starters, how many different batting orders are possible? 9 factorial. Because if you're doing a batting order, aren't you just lining up your 9 guys? And 9 guys in a row is 9 factorial. So we had that number on the board. but I don't
5
remember.
guys. 5 guys, 5 guys.
362,880.
Okay,
362,800.
there you go. So-
You already said it.
So I'm
sorry.
good on number
What was it?
15, does everybody understand? Right, come back to order. Now, how many are possible if the picture has to go last? 8 factorial, very good. Why is it 8 factorial? Because if the picture has to go last, your picture, right?
Yeah.
He's asked. So I kick him over here. I'm not gonna arrange him. I have 8 guys to arrange that, right? 8 factorial.
Because he's already guaranteed the last ball.
Exactly. How many are possible if the pitcher is last and the best hitter is third? 7 factorial. Because I pulled both of them out of line. I'm not arranging them. They have their spots. I have other 7 people, and that one's 5,004.
So can we do, memorize these factorials, not even need a.
What you wanna do, you can always do it.
I think I should make it so that should make it.
No, you're good.
Now, number 18, this is a good one to do here. Number 18 introduces a new concept. Number 18 says, we are going to use the digits 1, 2, 3, 4, 5, and 6. And we're gonna build numbers, just like you were building license plates, building call signs, you're gonna build numbers. But here's the difference. You are gonna be building 3-digit numbers, or 2-digit numbers, or 1-digit numbers, okay? All right, so let's start with 1 digit. 6, because there are only 6 numbers for you to pick from. So your 1-digit numbers would be 1, or 2, or 3, or 4, 5, or 6. Okay, that's easy.
Yep.
Now, what about the 2-digit numbers? How many of
36.
those would there be?
36.
36, because if you're building a 2-digit number, it could be some out of those numbers, it could be like 35, but it could also be 44, or 11, right? Okay. And then how about,
666.
okay,
Whoa. It's
So
216.
It's 216, this is 36, and this is 6. Now, here is, this is a big idea, all right, big idea.
What's the big idea? Airball.
Airball.
Here's the big idea. Since I have 216 three-digit numbers, I have 36 two-digit numbers, and 6 one-digit numbers. And I want to know how many I have all together. What will I do with those 3 numbers? Add them. That's an add. That's an add. Anytime, boys and girls, anytime you have a situation where it's this or this, you're gonna add. Now, some of you are thinking, well, wait a minute, we've been multiplying. Yes, because when we built this number, right here, for example, we had to make a three-digit number. So we had to pick a number and a number and a number. And when you are doing this and this, you multiply. When you are doing this or this, you add.
So or is add and is this.
What? And is multiply or is that? Yeah. Fries, nuggets.
All right,
Fries, and egg.
Chicken tenders, fried chicken.
let's take the letters of the word Chevy.
A bucket of chicken.
How many ways, basically, can you arrange words as in quotes? Because we're just making 5-letter arrangements, they're not real words. How many ways can you arrange the letters?
26 P5.
No, because it has to be the word Chevy.
Oh.
Yeah, you're good.
Wait, Chevy.
Isn't it? I did 5 powers. Is it just 1?
Would you be 5 factorial?
Five factorial, just
Okay,
like that,
Joe.
5 factorial.
How many thighs, breasts, wings can you fit in a
Here's what I want you
KFC
to
bucket?
think about.
Probably.
Stop. It literally says, take the word Chevy, all right? So how many letters are there?
5.
I'm gonna cut them out, so I have a C, and I have an H, and an E, and a V, and a Y. And then I'm gonna lay them down here on the desk. How many ways can I arrange those 5 letters? 5 factorial. 5 factorial.
Yeah.
Okay.
How many
Now,
combinations can you make?
what about the word pre?
720.
Pre-cal would be 6 factorial,
How many combinations
all right? Now,
of clothing can you make?
skip down to number 23. We'll come back and get the others after lunch, but right now, number 23. Pre-calculus, how many ways can I arrange the letters of the word pre-calculus?
11 factorial.
It's a big number.
How many letters are there?
39.
Wait, it is.
Yeah.
You guys were on number 23.
You don't need a projector. Somebody else.
Somebody said there were 11 letters up here, did you count them?
Yeah.
Now, there's something different though about this word.
They were repeat.
There are repeats. When there are repeats, we start with the total, so 11 factorial is where you start. But then, since there are 2 C's, I divide by 2 factorial. Those are the C's. Duplicates get divided. Now, there are also 2 U's, so I divide by another 2 factorial. No.
Two L's.
Each
2 L's.
factorial, and there's 2 L's, so another 2 factorial.
So 11 divided by 8.
So 2 factorial happens to be 2, 2 times 1. So the bottom is just 8, not 8 factorial, it is the number 8.
Yeah.
So you can type in 11 factorial over 8.
4.
It's going to be big.
4,989,600.
Okay,
Wow.
These numbers are going to be big.
Yeah, you did.
So I see Anna kind of looking at it weird, so I'm going to check. Sometimes she looks at it weird. No, 4,989,600 is correct.
I put it in yet.
He's looking too.
All right, one more, and then we're going to lunch. 24, the word Mississippi.
There's definitely.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 again. 11 factorial. Always start with your total letters.
4 factorial.
4 S's. 4 I's.
Wait, others.
2 D's.
4 S's.
Okay, so you got it? Okay, wait.
Whoa! Where's?
That's like going to lunch activity.
We are gonna type this in.
Okay.
Now,
Alright.
when you type it in, so 11, math, factorial. Now, you want to divide by all 3 of these. So what I do is, I say divided by 4 factorial, divided by 4 factorial, I keep dividing, no multiplication, divided by 2 factorial. Your answer should be 34,650, 34,650. As long as you're getting that, whatever you're typing in is okay.
Could you like keep like a power and put it over like the 2 factorial? So you don't like
Square it. I never squared the factorial symbol. Try it and see what happens. All right, go lunch. I'll see you back. 46. You have till 46.
I did not see you guys.
You're all crazy as can be.